in this video, we are going to be looking at another type of intermolecular force, and this is now the permanent dipole-dipole interaction, okay? Now, we've already looked at electronegativity and what that does to a bond. So, for example, if we have hydrogen chloride, okay, so it's got a covalent bond between the hydrogen and the chlorine. Because chlorine is more electronegative than hydrogen, the electrons in this bond have a greater attraction to the chlorine. Okay, so that means they're going to shift slightly more towards the chlorine. And what that does is it polarizes the bond, and then therefore the bond is going to have a dipole going across it. Because the electrons are lying closer towards the chlorine, chlorine is delta negative, and therefore hydrogen is delta positive. Okay, and that's what we call a dipole going across this bond over here. Now, this is different to the instantaneous dipole that we looked at in the previous video. Okay, an instantaneous dipole is temporary, won't last very long, but this sort of dipole over here, where we have an electronegative atom in a bond, this is what we call a permanent dipole. Okay, it's not an instantaneous dipole, this is a permanent dipole, and no matter what's around it, or no matter how much time goes by, this dipole will exist throughout. Okay, so this is a permanent dipole, and as you can imagine, there's probably a lot more hydrogen chloride molecules around, which also have a dipole going across them. And as we know, negative attracts positive, or opposite charges attract each other. And that means between the chlorine delta negative and the hydrogen delta positive on another molecule, okay, so on another molecule, there is going to be an interaction between them. Okay, there's a force of attraction between those. And this is what we call a permanent dipole-dipole interaction. Okay, so this is not an induced dipole-dipole interaction. If a molecule already has a permanent dipole, it's going to have permanent dipole-dipole interactions. Okay. Also worth pointing out that in my last video when we were looking at London forces, I said all molecules, regardless of whether they have any other type of intermolecular force, will have London forces. Okay, so these molecules between them do have London forces. Okay, so there's London forces and permanent dipole-dipole interactions between these molecules. Whereas if you have a non-polar molecule, so these are polar molecules here, if you have a non-polar molecule, so for example, if I do a chlorine molecule, so because they have the same atom, this bond here isn't polarized, so this is non-polar. So between chlorine molecules, you are going to have London forces only, whereas when you have polar molecules, you are going to have London forces and permanent dipole-dipole interactions. Okay, so it's worth bearing in mind that permanent dipole-dipole interactions are stronger than London forces. Okay, so this force here is slightly stronger than a London force. The London force is very, very weak, whereas a permanent dipole-dipole force interaction, is a lot stronger.